Good day. We are the Group 4, and the topic that we are going to discuss is nuclear density test. What is nuclear density test? Nuclear density test is a method used to quickly determine the in situ density and moisture content of a material to be tested. The gauge consists of a radiation source that emits radioactive particles and a sensor that counts the received particles. By calculating the percentage of particles that return to the sensor, the gauge can be calibrated to measure the density of the test material. This service is used by construction companies, constructors, and civil engineers. According to Billy Troxler, he originally presented the first nuclear gauge to the agricultural business in 1962. Shortly after, he did the same for the civil engineering sector. Over the years, technology has continuously advanced and the products are now acknowledged as the global benchmark for compaction control in highway and large-scale construction projects. When the Federal Aid Highway Act in 1956 was signed by President Dwight Eisenhower, the nuclear density test, which was originally designed for farmers, suddenly became essential to the construction and road building sectors. Eisenhower said that the law would remove hazardous roads, inefficient roads, traffic jams, and other obstruction to safe transcontinental travel by establishing a 41,000-mile national system of interstate and defense highways.
Hello, I am Monica Villanueva for the significance and use. Um, this is a method used by construction companies, contractors, and civil engineers to immediately give the client a reading of the density and moisture content of the materials in site without the need to bring a sample to the laboratory. The nuclear density test is helpful because it is a quick, non-destructive procedure for measuring the wet density and water content of soil and soil aggregate in situ, as well as figuring out the dry density. The test procedure is used for quality assurance, acceptance testing, and research and development purposes for compacted soil and soil aggregate mixtures used in construction. Because it is non-destructive, repeated measurements can be made at a single test site and the data can be statistically analyzed. For test specimen and sampling, the procedure is able to test on soils, aggregates, and bituminous materials. The sample should be taken from a region directly under the gauge when sampling for water content correction or oversized particle correction. While utilizing the direct transmission method, the zone has a diameter of roughly 200 mm or 8 inches and a depth equal to the probe's depth setting when using the backsetter mode. The zone's depth is roughly 75 millimeters or 3 inches.
For the apparatus used for this procedure is the nuclear density gauge. To use this machine, when the rod of the apparatus is inserted into the sample to be tested, the machine emits gamma rays toward the tested material, which react to the electrons of the tested sample. Samples with a higher density give higher chances of redirecting gamma rays back to the sensor of the machine.
Given the calibration factor, the software of the apparatus used will be automatically calculate the density of the sample after it has received the redirected gamma rays, with the results being based on the percentage of gamma rays sent and returned.
This is Jeffrey Stevens, and for precision and bias, since the calculations are done by the apparatus itself using software, chances of human error are greatly lessened. By this, more accurate results will be observed.
So for the summary or the conclusion, we concluded that the nuclear density test is a method that can immediately determine the in situ density and moisture content of a sample with the use of an apparatus that emits and receives gamma rays. Moreover, Nuclear moisture/density gauges are testing devices that use low-level radiation to measure the wet density, dry density, and moisture content of soil and granular construction materials. This also uses the nuclear gauge for the measurement of the wet density only. That is all for the conclusion.
Recommendations: even if the apparatus for the nuclear density test is using software, it is still recommended to use this method with several repetitions of the procedure to ensure accurate results. Also, caution is advised since there's a presence of gamma rays when using this procedure.